Hi guys, Mrs. McDowell here. Since I'm gone today and we want to kind of stay on track for finals and our test, we're gonna try something different. So you can get out your notes and pause whenever you need to keep up, and we'll just go from here. So today we are going to talk about section 8.3. And when we talk about 8.3, we're going to talk about formulas for ionic compounds. Remember, when we've talked about ionic compounds are the ones that have charges, and they are going to form crystals. So today it's really important that we focus on how scientists communicate. And for them to communicate, they need to have chemical formulas, and they need to be able to name the compounds so that everybody can understand them. And to do that, they have a standardized system for naming things. When we talk about ionic compounds, they can be broken down into what we call formula units. Formula units represent the simplest ratio of the ions involved. So when we're putting them together, we need to make sure that the charges balance so that we can have a neutral compound. So the charges need to add up to 0 for it to be considered neutral. When we talk about ions, there are a couple different types of ions that we're going to talk about. And the first type of ion is called a monatomic ion. Remember, the prefix mono means one. So these atoms are one atom ions. When we talk about one atom ions, they always have the same charge. And when we look at the charges, we often call them oxidation numbers or their oxidation state, and that's going to be the charge of the monatomic ion. And if you look at the table 7.7 below, these are those trends that we talked about that have to do with their group number. So group 1 has a +1 charge because it wants to lose that one ion. Group 2 has a +2 charge because it wants to lose the 2 electrons in its outer shell. But when we skip over to group 15 or 5A, they have 5 electrons in its outer shell. Remember, we want to get to an octet or 8. So to get to that 8, what's it easier to do? Lose those 5 or gain 3? Well, they're going to gain 3, and since electrons are negative, it's going to get a -3 charge. Group 16 is 6A. It's going to get a -2 charge when it gains. And group 17 is going to get the -1 charge because it just needs 1 to get to 8. Now, when we look at, there are some rules that we can talk about for writing formulas. Okay, the first rule is that the symbol for the cation is always written first, followed by the symbol of the anion. Well, remember, the cation is positive. So the positive ion, which are going to be your metals or things on the left-hand side of the periodic table, are going to be written first, followed by the symbol of the anion. The anion is the negative ion, and these are going to be usually your nonmetals, things that are on the right side of the periodic table. The second step is that we need to use subscripts. Subscripts represent the number of ions in each element in an ionic compound. So these are going to be written below, attached to the element to show how many that we need. So like when we talk about H2O, the 2 is a subscript showing us that we have 2 hydrogens. When we use our subscripts, we need to make sure that the total charge equals 0 in the compound. And we have to use the ionization numbers to help us determine this ratio. So to figure out what subscripts we need and how to get our charge to balance 0, we need to use those oxidation numbers to come up with that ratio. So let's look at some examples. An example would be potassium and oxygen. So if I have potassium, let me find my little marker here, just a second. All right, if I have potassium, which is K, and its charge is +1 because it's in group 1, and I have oxygen, and its charge is -2 because it's in group 6A, it needs 2 more to get to 8. When I am looking at these two things, I want this total between these two to equal 0? Well, right now they don't. 1 and minus 2 does not equal 0. So what I need to do is I need them to balance out. Well, the easiest way to do that is cross multiply. I can take this 2 and I can put it down here. I don't need to cross the 1 because I don't need an invisible 1 here because I already have the oxygen there. But if I take a plus 1 times 2, that's a plus 2. And I take it minus the 2, that balances out to 0. So my formula for potassium and oxygen is K2O. And I can just write it just like that without the charges. K2O. Alright, so let's do aluminum and sulfur. Al, if you look up its charge, aluminum has a plus 3 charge. And sulfur has a minus 2 charge. Well, I need to get both of those to equal 0. So the easiest way is to find the least common multiple, or we can cross multiply. This comes down here to equal 2. This comes over here to be a 3. This would be plus 6. And this would be minus 6. And that is going to equal 0. Okay, so that's the mathematical way to find the formula for an ionic compound. You can look at the practice problems on page 224 for some examples, and Mrs. Sass can give you the answers to those after you are finished. Okay, so let's move on. Now, the second type of ions that we have are the polyatomic ions. These ions are made up of more than one atom. Poly means many, and so these atoms have more than one atom involved. Okay, so if you see there, ammonia on this side over here has several of them in there, nitrogen and 4 hydrogens, where this phosphate has potassium and 4 oxygens, but it still has a charge. So they're going to exist as a unit. I can never change any of the subscripts that are here within this ion. This whole thing exists together with that charge. I can't change the subscripts that are there. If I need to add more than one of them, I need to keep my parentheses and I can add a subscript after the parentheses like this to be able to show that I have 3 of that whole thing or 2 of this whole thing. And I don't change the amount of them in the individual. Okay, this is a table showing the common polyatomic ions. You will get a copy of this for your test when we are looking at these polyatomic ions. So you don't have to memorize them, but you will have a copy of this on your test. Now again, you can look at some examples on page 225 and look at the answers. So for example, if I were doing sodium and nitrate, which is number 24 on page 225, sodium is a plus 1 charge, nitrate is a minus 1 charge, so it would just be NaNO3. Go ahead and do 25 and 26 and see what you get. Put those in your notes. The next type of ions are called oxyanions. These are a special type of polyatomic ions, and these are composed of an element, which is a nonmetal, bonded to 1 or more oxygens. So they're going to have different types of oxygens, and there are special kind of rules that go along with your oxyanions. When we look at our oxyanions, they have different rules in there. They're in these tables here. But when I'm looking at them, if I have the greatest number of oxygen atoms, it's going to be followed with an 8, and the fewest is going to have an 8. So you just kind of have to memorize that and look at the chart and be able to kind of tell the difference. If it's an 8, it's going to be the higher number. If it's an 8, it's going to be the lower number. Excuse me. Now, sometimes for chlorine, there are actually more than just 2. There's actually 4. And so here are some other rules that you can look at, and these are in your books. for looking at the chlorate ions. We're not going to look too much at that. Okay, well, here's some rules, which is called chemical nomenclature for naming compounds. First thing is you have to name the cation followed by the anion. And for monatomic cations, you're just going to use the whole element name. For example, potassium. I'm not going to change that. I'll just use the whole thing. For monoatomic anions, use the root element name and the suffix "ide." So potassium, and we could change it to oxide. Potassium oxide. I'm going to use the root of it and put IDE at the end. Now, if it is going to be one that has different oxidation states, like our transition elements, ones that we can't predict, so like copper or iron and other things like that, we need to use the oxidation number in parentheses. So the oxidation state is written in parentheses after the name of the cation. So for example, I would use iron, parentheses, the Roman numeral 2, oxide. And then I would write, if I'm writing the compound as a polyatomic ion, I just name that polyatomic ion by looking it up at my chart. Here's kind of a flow chart that gives you some examples of things. The first thing that I need to do is determine the cation and the anion of the formula. Then I need to ask myself, does the cation have one or more oxidation numbers? If it only has one, then I'm going to simply write it the way that I need to with the appropriate ending. If it has more than one, I need to include the charge in parentheses, like here with the iron. Is this iron +3, not a 2, not because I just have 2 of them, but it would be a +3 charge because of oxygen being -2, and I cross multiplied to get that to come out. So I need to look at those examples there. All right, so open your book to page 226 and let's practice naming a few of those. So if I look at NaBr, that is just a plain basic ionic compound. So I would name my cation, which is sodium, and my anion is bromine. But I don't use the INE, I would use the base and I would change it to an ide. So it would be sodium bromide, IDE. Look at number 31. Okay, potassium is my cation, but the OH is a polyatomic ion, and I would look that up, and that's called hydroxide. Potassium hydroxide. Excuse me. So potassium hydroxide. Then I would look at 32. 32 is copper is a transition element, so I'd have to look up its charge and have to figure that out, and I can look at that from the base. First thing that I need to do, let's work this one out. If I have Cu parentheses NO3 with a 2. I would look up, first thing that I need to look up is the nitrate right here, the NO3. Nitrate has a charge of -1. So this is a -1 charge. But if I have 2 of those and no number here, then that means I'd have to cross that up here and my copper would be a +2 charge. So it's going to become copper and I need to put in parentheses my Roman numeral number 2, and then I just write out my polyatomic nitrate. All right, you can finish practicing those from that page. Okay, look through this section check. I'm going to quickly go through that. And your assignment that you need to do is right here. Good luck, and we will see you when I get back.